physically to the class. So we will have the class today, only today, on OLAN. And by the way, I am recording it such that at another time you can come back to watch the class if you want to. So, any question? Is there any question from anybody before we start? Okay, so here we start our class. The other time I explained to you a few similarities between 101 and 106. More specifically, I explained a few things to you between C programming and Java programming. So we will move to writing programs. So we start from here, elementary program. Is there lab this week? Let's complete the class today. By the time we complete the class today, if I believe that we have covered sufficient material for a reasonable lab, then I will announce to you, not just by voice here, because if there are students who miss this class, what I tell you here, they won't know it. So I have to announce in a way that everybody can get the information. So let me complete the class today. If I judge that you have done sufficient work, then I will, okay. If I judge that you have done sufficient work, then I will announce the situation of the lab. So I am verifying everybody just in case you need to do some things that is limited. All right. So last class also, I mentioned something about the new set of slides that we are using in the university. These new sets of slides have this area, the green area. So whenever you see a green area, you can click on it. If you click on it, it takes you to the website of the textbook, and you can see the code for the discussion on the slide. So here, since you can write this in C, so I'm going to explain in an abstract way. So here we are talking about the area of a circle. This program computes the area of a circle. What does the program look like? Here is it. In C, we just have a main program, a main function. But I told you that C is not Java. Why? Because C is not object-oriented. And because C is just a procedural programming language, we don't have classes inside of which we put methods and we create objects. So here we have the first thing, which is a class called compute area. And like I said to you the other time, the name of classes must start with capitals. I guess you can see my mouse. The name of classes must start with capitals. So this is the main method. The way you have the main function in C, this is the main method in Java. We have a variable here called radius. This is pretty simple to you. Then the next is you have another variable called area. The radius and area are declared variables, but they do not have initialized values. So at this point, there is no value. Here, we are trying to assign a value to radius. We move down, we compute area. Area, from what we know, is pi r square. So this is the pi, this is r square. Now, you can do this since you are professionals in using C. You know how to compute r square. R square from our C is power into bracket radius, comma 2. But this is Java, we are starting with the basics. So we are not trying to use extra classes for our operations. We are just doing basic arithmetic. So this is radius square, then times pi. That gives us area. Here we print the result. So let's step through the code. Let's trace the program. By the way, you would have codes like this in your exam, where you would trace the flow of the program. So let's assume that we have code like this in the examination. I can make it, let's say 5 times, and I ask you that at the third time, what is the value of area? Something like this. So this is tracing the program task. Let's move to the next slide. By the way, the slide materials are online, so you can study and try to move on with the class. So here we said that we have just declared the variable. We have not initialized the value to it. And that is why here we have no value. When we move to the next slide, it says we have allocated memory for the variable called radius. And from what you've learned in C, we have allocated memory of type double. This is important. Remember, we discussed this in C, that variables are allocated memory based on their types. So we have allocated memory for variable called radius, and that variable, now that memory space is of size double. Okay, so let's move to the next slide. Now we evaluate the next line, double area. It's the same thing as what we have here. Area is created, memory is allocated, but no value. Why? Because it's just declaration. There is no value. All right. So we move to the next part. What is going on here? We now have assigned a value to radius. So at this point, radius was without a value. But now radius has a value, and the value is 20. So we have the arrow telling us that now we have updated the value of radius. With this, we have everything we need. We have a constant for pi. We have the value of radius to be 20. So we know that 20 times 3.14159 should be the value of area. So when we move down, it's going to be 400 times 3.14159, and that gives us 1256.636. So this is the value of area. Right down here, we try to print a string. All of this just come from the knowledge you have in C. We try to print a string from here to here. We concatenate. Okay, this is different in C. So I think I should demonstrate this to you. So in C, this line would be printf. Then we write the area for the circle of radius. Okay, it's double, so we just put. Okay, but let's write it as long float. Now, remember in C, we will put the variables we want to print after the comma. So this would then be radius, comma, area. But the difference is that in Java, we don't use this placeholder for print line. So for print line, we don't use this placeholder. Instead of using the placeholder, we end our string by putting this quote. So we say, okay, this is the end of the string. Print this string exactly the way it is. But instead of putting the placeholder of %lf for a float, we don't do that. We do what is called concatenation. In Java, what we do is concatenation. So instead of putting the placeholder, we put the value itself in print line. If we are using print line, we put the value itself, but we put the plus sign in front of it. This is important. We put the plus sign in front of it to say, okay, add radius to it, and we are not done. We should add some other extra strings that would come up later. Now, if you observe from the code, the modification I've made to the code, I have damaged everything after radius because is meant to be a string, but I already closed. Is meant to be a string, but I already closed the string here. So it means we have to open a new string. Again, we said that we cannot use placeholders in print line. So we remove the placeholder. And what do we want to print? We want to print area. We concatenate the area to what is going on, plus area. So the rest, we don't need them anymore. So this is a very important difference between the printing in C and in Java. So this is the difference here. The area for the circle of radius, instead of percentage whatsoever, a placeholder for the variable, we end the string. We introduce the variable itself directly into the expression. We introduce the variable itself directly into the expression and we concatenate it. The plus operator in the string is called concatenation. It helps us to join two things together. It's called concatenation. Let me write it here for you. Plus operator is addition in arithmetic expressions, but concatenation in non-arithmetic expressions. This is important. It's called concatenation. It adds things together without changing their logical meaning. Okay, so let's go on. Let's remove this from our screen and we continue. So area didn't have a value before. Now at this point, we have value for area and we set the value back into the variable. Okay, so here's what we have. The area for the circle of radius rad, which is what we concatenated here, this radius, is what we also concatenate next. Oh, may I ask again? Usuti is saying that she can't see my screen. Can you see my screen? Can other people see my screen? Please write in the chat. Or you can unmute yourself and speak. Okay. So probably those I have not verified can't see my screen. Maybe because of this. Just a moment. Let me verify everybody again. Ursut, can you see now? Oh, great. Okay. So I think in that case, I have to verify you from time to time. And by the way, thanks, Usud. Thanks for letting me know that you can't see. So probably others also are there that couldn't see. In case you are there, you can't see me, or when other students come in and they can't see, I really hope somebody can inform me such that I can verify them. Okay, if you understand, let's continue. Next, we want to get input from the keyboard. And to get input from the keyboard, again, let's visit our C code. To get input from the keyboard in C, what do? We use the scanf. We say scanf. We put a string. We say this is the type, comma, destination. I believe you agree with this. So we put the type of the variable we are trying to put the value in, and with the ampersand, we specify the location we want to store the value. This makes sense to everybody. So let's compare this to the approach that we have in Java. In Java, since everything is an object, we have to make sure that we use a class called scanner. Now, what is this class called scanner? It's a class that is predefined in Java. It already comes with Java from the box. It's not a class you have to write by yourself. It comes with Java, and as it comes with Java, it gives us the functionalities of getting input into the Java environment based on the type of value we want to get, either integer or float or double or whatsoever. So let's write on. Let's see. Okay, we are done with this part. Let's keep scanf and discuss. So here is it. To get input into Java, it is completely different from what you are familiar with in C. So please observe what I'm doing very well now. In C, you call destination, and then you must create a variable called destination. And after creating the variable, you must put the value in it. But in Java, the first thing we do is not getting the value. The first thing we do is creating an object from the scanner class. Please observe me. Here is what we do. We say we need a new scanner. I hope you are with me. We say we need a new scanner. And this scanner is in system.input. So this is what we are doing. We are creating a new object from scanner. But based on Java's policy, whenever you are creating an object, you must mention the name of the new object you are creating. You have a factory, the factory wants to produce a car for you. Your car should have a name. And that is why we will start with, okay, my input. Here they wrote input, but we can call it my input. So let's say my input is equal to new scanner. So what we are doing is we are telling the Java system that we want to get input from the keyboard. And because of that, we need an object that can help us to get input. That object should come from the scanner class because the scanner class is our class for getting input. And please, when you create that object, give it a new name. The name should be my input. Please, the name can be anything you like. It does not need to be my input. Please keep this in your mind. Now, the next thing is this. Let's go back to basic C. How do we declare a variable? We say int x is equal to, let's say, 55. I guess I'm right. What have we done? This x is the value you are putting, this 55 is the value you are putting in x, right? And that is this. This is the value you are putting in input. This is the assignment operator. We have it here also. It's the assignment operator. What is the next thing? The destination is my input. We have the destination. It's also like this. It's x, like my input. The only thing that is missing now is what is the type of x? It is integer. If you look here, we are creating my input. What is the type of my input? It is coming from the scanner class. So we have to say, okay, we know the type. It is of type scanner. And this is the first line in preparing to get keyboard value in Java. We create an object of the myScanner class, and we use that object to get the value into Java. So what do we do next? Next, we say, all right, we want to get an integer. So we say integer y is equal to my input. Remember, my input now is a very big boy that was created by Scanner. So my input is enough to do its job. It forgets about the mother called Scanner. So it can do the job by itself. Dot next int. This is the idea. Observe that I wrote next int. Why? Because we are trying to get an integer to y. Y is an integer variable. That is why I am using next int. So let's look at our example. So the example says, after we create the scanner, which is called input, we already explained this. From that time, we forget about scanner. We begin to use input because input can do the job. So we say input dot next type that we want to store. Next type. The type is double. So it should be next double. This is important. If it is not double, then it should be that type. So here it is next int because the type we want to store in is int. When you begin to do practice, I think you would start your lab this week, maybe, if not next week. But when we begin to do practice in the lab, the assistant would ask you to do something like this. It's important for you to realize that if you are storing in a variable that is double, then you must use a next double. If your variable is an integer, then you must use a next integer. Okay, just a minute. Let me go through the messages I have so I can clear everything. All right. So again, you have the slides. You can follow this to look at the code. Please play with the code because you would have a lot of code tasks in your examination. Most probably you would not have basic things. You would have code tasks. Now you are familiar with code. Yes. Next thing is this. Let's go back to C. Let's put the space. Okay, I explained this already. We don't need to do this anymore. This is from C. Now let's go back to C. In C, before we can use scanf, what library do we have to include? Who knows the answer? I'm waiting. If there's anyone who knows the answer, please write it in the just write in the chat. We want to use scanf. Scanf is from the input and output library. So what do we write before we use scanf? Okay, yes, nice, Jeyun. Thank you, Jeyun. But it should be longer than this, not just stdio.h, you know? So in C, we would write hash include stdio.h. And the equivalence of this in Java is Java. Okay, we have to import java.util.scanner. So this is the direct equivalence of hash include stdio.h. Now, you could be looking up here and say, oh, what is this? This is different from what we can guess from C. What this means is wildcard. This is called a wildcard. Let's write it here. It's called a wildcard. What wildcards mean is that it brings everything that we have inside of the util family. Inside of this utilities family, it brings everything, not only scanner. When you add scanner like this to the path, you are saying from the utils family, give me only scanner so I can use scanner. But when you do this, you say, I heard that we have many guys in the utils family. I want to see everybody. This is the meaning. Now, there's an important question that can come to your mind in code optimization. You could say, oh, this is bringing everybody. This is bringing only one. This guy that is bringing everybody may be very bad. Why? Because it is bringing everything, including what we don't need. So we might have too many lines of code. The implication is no, we will not have a problem. Why? Because the Java system has what we call an optimizer. So what that means is when you type your code, okay, everybody is listening. Everybody in the wildcard is thinking that you will use them. But when you finish your code, the code compiles only with the ones you actually used, not with everybody that can join. So by the time the code compiles, we have forgotten every other 9,999 guys. We have picked only one, which is scanner, because only scanner was used. If you look here, only scanner was used. So that is why we say there is no performance difference. Because at the end of the day, the Java optimizer helps us to optimize the code that will be compiled so that we don't compile every possible class that exists in the utilities library. Okay, identifiers. Identifiers. Okay, let's think. What is an identifier? I don't need you to tell me this. This is what identifier contains or does not contain. My question is, what is an identifier? Because I mentioned this in C. I'm waiting for somebody to write it in the chat. What is an identifier? I'll wait for 1 minute. Okay, Burama says is the name of a variable. Thanks, Burama. It could be, thank you, Sheima. Sheima took it one step forward. Sheima says it could be variables, functions, anything. Nice. So, actually, let me give you the definition of an identifier. I'll write it on the screen again. Let's say, so any part of a program that has a name is called an identifier. So that name is an identifier. Why? Because when you create a function, you call the function based on a name. That means you're identifying it based on that name. So an identifier is the name that is given to a program element. So with that name, we can make use of that program element. So a variable is an identifier. A function is an identifier because it has a name. All right. So let's continue. So identifiers in Java. Remember this, that we are not just talking about all identifiers. We are talking about identifiers in the Java programming language. It's a sequence of characters that consists of letters, digits, underscores. This is underscore. Digits is 0 to 9. Letters would be A to Z and small letter A to Z. It's important for you to remember that cases matter. So, and a dollar sign. These are the things allowed in Java. Letters, digits, underscores, and dollar sign. You cannot say the name of your variable is X star Y. This is not a valid variable. Why? Because star has a job in in Java. And because of this, there is complete restriction on the use of symbols as part of the names of variables, except the dollar sign and the underscore. You should not use minus because minus is subtraction. Okay, an identifier must start with a letter, an underscore, or a dollar sign. Now we have a new change. The change is that even though an identifier can contain digits, it must never start with a digit. This is very similar to what we have in C because from what we discussed in class, C is the father of Java. So Java is from C. Okay, I guess there's nobody who can't see my screen. If there's anyone who can't see my screen, please let me know. I should verify you. Though I can't see the verify button at the moment, it seems everybody is verified. But if you are there, you can't see me, please let me know if you can't see my screen. An identifier cannot be a reserved word. This is important. Mahmoud, you can't see me? What's going on? Let's check why Mahmoud can't see me. Mahmoud should be able to see me. Why can't he? Because Mahmoud is already verified. Probably there is a part of the screen that you are not looking at. You should. Under normal circumstances, you should. But if you try again and you can't, please exit the class and enter back. You should normally be able to see me. Great. Okay, let's continue. Okay, somebody else is reiterating what I said. Somebody says, did I say C is the father of Java? Yes. Here is the idea. Probably I didn't mention this clearly enough in the class. Programming languages, most of them evolve from existing languages. So from C, we got a variant of C called C++. C++ is an object-oriented programming language, but it inherited some bad things from C. I mean, bad based on how programmers look at it. So A new programming language was developed called Java. And this new programming language tried to remove some things that are not good, that they think are not good from C++. So indirectly, C++ is from Java and some other languages. While Java is from C++, and also it took some features from other languages. But C++ is from C. So C is like the father or the grandfather of Java. Okay, let's continue. So we have reserved words. What are reserved words? They are those words that you cannot use as identifiers or like a variable, like the name of a method. Why? Because they already have a job in C. Oh, in Java, I mean. An identifier cannot be true, cannot be false, cannot be null, because all of these are already reserved. It cannot be int. An identifier cannot be int. An identifier can be of any length in Java. So here is an example. You can look at this. It's easy to understand because you have seen it before. Radius is 1.0. Here we have a change to radius. It's now 2.0. No, libraries are not the same as classes. No, they are different things. At some point, functionally, they can be the same thing. Like earlier, we said that we would include stdio.h library. Okay, if we consider that with including scanner, functionally, they do the same thing because scanner helps us to get input. Stdio.h helps us to get input in different languages, but structurally, they are completely different things. They are different things. But at some times, functionally, they are similar. So declaring variables. Here we have x and it's an integer. Here we have radius, it's a double. We have a, it's a char. You are familiar with all of these. We don't need to waste time. X is 1 now, so we are assigning values to it. Right is 1.0 because it's of type double. So we are assigning floating point value to it. And a is a char, and so we are putting a single character inside of it. So we can, like we do in C, we can declare the variable and initialize at once. It's about the same thing. Next is constant. In C, when we make a constant, what do we write? I need someone to write that in the chat for me, please. What do we write when we make constants in C? I don't understand what you mean by for shortcut. If you want to make a constant, not a variable, you want to create an identifier that holds a value, but that value cannot vary, cannot change. Like what we have here. This is a variable. The value of radius can change. Here it is 1.0, in the next time it is 2.0. So this can change. But if you want to make an identifier that cannot change, what do you write in C? Yeah, thank you, Burama. But what is going on today? Everybody is not writing complete code. Everybody just say define. It's hash define. It's hash define. So here is it. In C, we say hash define. Here they have constant name and the value. An example is pi. Let's just use J. Define J 100. So we've just said, now we want to have an identifier. The identifier is J. The value of J is 100. But this identifier is not a variable. It cannot change. So please don't allow anybody to change it after we have defined it. That is the meaning. So this J is a constant and it cannot change. In Java, we write constants by putting the keyword final in front of the declaration. It's exactly like you're defining a variable. The only difference is that before the type of the variable, you put the final keyword. Naming convention. Okay, if you have to name a variable, you give it meaningful names. It should be easy to understand. Methods nothing should start with uppercase except class. Only a class starts with uppercase. All other things must never start with uppercase. Okay, capitalize the first letter of each word of the name. This is important for classes. The first letter of the name of the class should be in capitals. For constant, it is good to write the name of the constant in capitals so that in your code you can easily identify that it's a constant. All right, so here are types that we have in C. Oh, come on, in Java. In Java, we have extra types that we don't have in C. So here we have byte. What is a byte? A byte is 8 bits. So since all types in Java are signed, if you observe, everything is signed. We have minus and then two plus. So every type in Java is signed. In C, we have signed and unsigned integers. But in Java, all the numeric types are signed. And because of that, we can have the negative and we can have the positive for all the numeric variable types. So what that means is the most significant bit used to store every variable keeps the sign. You should remember this. I think I explained this several times in C. The most significant bit holds the sign. So if you take a byte as an example, how many bits is a byte? It's 8. So 1, 2, 3, 4, 5, 6, 7, and finally 8. These are the bits that make up a byte. But we are saying that since Java ensures that all variables are signed, the most significant bit, which should be here, we should have the largest size, is for the sign. So it is going to be 1 if the value of the variable that is stored here is negative, or it will be 0 if the variable is positive. And that means we have only 7 bits left to store the character. And that 7 bits will give us only 128 options. And that is why we go from minus 128 to 127. So a byte has only 7 valid bits. If you put much more than that in the byte, you would have a problem because it would be unable to store it. Okay, we have short. It's a bit larger than byte, but it's smaller than an integer. We have int, which is larger than short, but smaller than long. We have long, which is the largest of the whole numbers, the largest of the integer types. That is long. Then we have float and double in Java. Okay. Earlier, we talked about next double, but you probably need to know that we can take much more than double and int. So here are the other options that you can have if you want to get input from the keyboard. Numeric operators. These are numeric operators you are familiar with. This is addition, subtraction, multiplication, division. And this guy is the guy we introduced ourselves to in 101, the modulus operator or remainder. This guy helps us to do the opposite of this guy. It gives us the remainder after a division. Okay, I don't need to explain remainder anymore because I believe that you still remember it from C. Okay. This also you know from C, the approximate nature of floating point. Because floating point stores value as points something, 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 it could be as large as required or as large as limited by the storage of the programming language and computer hardware. So it means that we could have limitation. Here is an example. If you try to compute the value of pi, what would you have? The value of pi, which is 22 divided by 4. Oh, by the way, I wrote 22 divided by 4. That's strange. What happened? Okay, so pi is 22 divided by 7. Here we have how many digits? I guess this is 15. Yes, this is 15. We have 15. But the truth is that mathematically, pi does not have an end. pi is a set of infinite numbers. There are still researches going on what is the 1000 value of pi. It's a lot. So what we are just saying is that this calculator is telling us a lie because this is not the full value of pi. What the calculator is showing to us is just an approximate value of pi. And this is what we are saying is the limitation of floating points. Because sometimes floating points are forced to give us just a small portion. Let's say we have 10, let's say divided by 2.5, we get a fixed value. And this is easy. If we say 10 divided by 5, we get 2. Or maybe even better still, we can say 5 divided by 2. It gives us 2.5. This is easy. But there are divisions that would not give us this kind of value, that would give us infinitely recursive value that we may not be able to get to the end of the values on a single screen. And because of that, it has to be cut. That is what we call approximation. So we are saying that floating points usually are approximated. Operators for exponentiation in Java. We have different operators. Example is the power operator. Just like we have in C. This, if you want to have 2 raised to power 3, then you put 2 here and 3 comes here. It's the same with the usage here. This is 4 raised to power 0.5, which is mathematically equivalent to square root of 4. Any question? Any question from anybody? Let's wait for 10, 20 seconds. Any question? Please write your question in the chat. Please unmute yourself. Ask a question if you have a question. Even online, you don't have questions. Nah. Let's continue. Literals. What are literals? A literal is a value that can appear directly in a program. That's a literal. A literal is a value that can appear directly in a program. Here is an example, 34. Okay, I guess this is 1 million. And this is 5.0. All of these are literals because they can stand by themselves. Okay, an integer literal can be assigned to an integer variable as long as it can fit into the variable. So we say that an integer literal can be put inside of an integer variable as long as it can fit into that variable. This is really important. Here it is integer I, it's large, int is large. But in case we have a byte, remember we said byte uses only the 7 significant bits. So it stops at minus 128 or plus 127. If you try to say byte x is equal to 500, your code will not compile because 500 is larger than 127. So that is the meaning of this, as long as it can fit into that variable. A compilation error would occur if the literal were too large for the variable to hold. For example, if you try to do this, byte b is equal to 10,000 or 1,000. Let me ask, why would this throw an error? I need someone to respond to that. Why would this throw an error if I tried to do this in Java? Why would this return an error? Okay, I'm waiting for you. Why would this expression, the one in the red box, why would it provide a compilation error? Golden, are you there? Okay, it seems somebody's replying me already. Nice, Burama. Nice, Golden. Thank you so much. So 1000 won't fit into B because B is of the byte type. And the byte type, the largest positive value you can put in it is 127. So you would have an error. Yes, thanks, Dana. Thanks. Great, great. So it seems you are understanding. I'm happy. An integer literal is assumed to be of the int type, whose value is between minus 2 raised to the power 31 and plus 2 raised to the power 31 minus 1. So what this means is if you make a variable and you say my variable is int v and you want to assign a value, if you assign a value that is larger than this, your code will not compile because this is the largest value you can put in an int. So if you want something larger than this, then you should use a long. So to denote an integer literal of the long type, append it with the letter L or L. L is preferred because L, lowercase l, can be easily confused with 1. If you observe, L looks like 1. This L, it looks like 1. So it is advisable not to write L. It's advisable to use the capital L. Now, what do you do? If you want to have a value that's of integer type, and you want to put it in a variable, you should put L after the value, after the literal, such that it tells the compiler that we are making use of a long integer. Floating point literals are written with a decimal point. You know this. By default, a floating point literal is treated as a double in Java. This is important. A floating point literal is treated as a double in Java. For example, if you write 5.0 in Java, it is not float, it is double. If you want to make it float, then you have to write 5.0f. This is important. F in capitals, like we mentioned in the previous slide for long. F in capital. So if you want to make a number to be a double, then you put D after the literal, something like this. For float and for D. So difference between double and float, you know this. Double is larger than float. Also, we have scientific notation. Scientific notation helps us to save space. So if we want to write a value that is really large, instead of writing 1.23456 plus e, you know this, raised to power 2. You can simply write it as this, or you can actually shift the decimal point around. So it's important to understand this for scientific operations. Now, expression evaluation. Though Java has its own way to evaluate an expression behind the scene, the result of a Java expression and its corresponding arithmetic expressions are the same. So you can safely apply the arithmetic rule for evaluating a Java expression. So evaluating a Java expression is basically like it looks visually. So you solve parentheses first. After you solve parentheses, you solve higher order expressions from left to right. So you solve the multiplication and then you solve the multiplication, you solve the addition, you move on to the resulting addition, and then you move to subtraction and you have your final answer. Okay, this is about computing time in Java. You can find the code here. Please find the code and play with the code. Augmented assignment. You know this from, I'm sure you know this from C. So we don't have problem identifying what these are. So these are augmented assignments, or we call them compound assignments in C. And we have increment and decrement operators. In C, we already talked about this, and this is prefix, this is postfix. At least for the students I taught C, you are very familiar with this. If you didn't know this, you would have failed the exam. So this is prefix, this is postfix. What is the difference? The location of the operator. If the operator comes before the variable, it is pre. If it comes after the variable, it is post. Do you want a break or you want us to continue? We continue and we finish sometimes early. Great. So we continue. So we continue. All right, so I is equal to 10, its new num is equal to 10 plus I plus plus. What is I? I is 10. 10 times I plus plus, what does that mean? It means you should multiply 10 with I, but plus plus means you don't change the value of I on this line. And this is important because this is post increment. So the value of I stays as 10, and we take 10, we multiply it by 10, we get 100, and we later increase this from 10 to 11. But here, what we have is pre-increment. So what happens is that before it even tries to evaluate 10 times anything, it first solves the pre-increment first. So this guy changes from 10 to 11. And so we multiply 10 by 11. Using increment and decrement operators makes expression short. But sometimes it can make the expressions to appear complex or confusing. But I know that you are very intelligent students. It won't appear confusing to you because you already passed C. So you know how to use them, you know where to place them, you know where not to place them, you know how to evaluate them. Okay, so avoid using these operators in expressions that modify multiple variables or the same variable for multiple uses. This is important. So you don't want to have plus plus I plus I. Why? The idea is simple because this is pre-increment, but you're having pre-increment when the value also affects another part of the expression. It's a reckless way of writing code because it depends, the result of this expression depends on the direction of compiler evaluation. If the compiler evaluates the value from right to left, then you have a problem. Because if another compiler evaluates it from left to right, you will have completely different answers. And because of that, whenever you want to use this kind of operator, make sure that in the same expression, you don't have a repetition of the same variable. Type conversion. So you are trying to put 100 inside of I, it's fine. Because 100 is lower than plus 127, so it's fine. On next line, you want to store k, and for the k, you are using I times this. But the problem is the compiler cannot evaluate different types. These three may be of a type that is different from I. So what happens? The compiler needs to make sure that I and the result of this expression are the same. When the two of them are the same, by implicit conversion, we should remember this from C, implicit conversion. When the result 3 plus 4, which is 7, when 7 and I are sure to be in the same type, the compiler multiplies them together, it gets 700, and converts that 700 to a long in K, because clearly 700 cannot fit in I, which is a byte. So as it tries to store 700 in K, then it converts 700 from byte to long. And it's the same idea here. Now we are dividing long by 2. We are multiplying I, which is a byte, to a floating point. What happens is I, which is a byte, is smaller than the floating point. So I is promoted. So I is promoted from byte level to floating point. The multiplication is done. K, which is a long, we are trying to divide it by 2, which is any type. 2 could be int, could be byte. So what happens? We are taking 700, which is a long, and we are going to convert 2 to the type of the larger one, which is long. We get the result of float or double and long. What is going to happen here? Because float or double is larger than long, then this part, which is K 700 divided by 2, 450, so 450 will be converted to float. So it becomes 450.0. It's converted to float. You add it to the floating point result of I times 3.1. Whatever you get, then you take it and you convert it to type double and store inside of D. So here are the conversion rules. Very similar to the ones that we have very similar to the rule we have in Java, in C. When performing a binary operation, by now I'm very sure you know the difference between binary operation and unary operation. When performing a binary operation involving two operands of different types, Java automatically converts the operands based on the following rules. If one of the operand is a double, the other is converted into double. Why? Because in memory hierarchy, double is the highest. So if we are having double and any other type, byte, float, int, we convert all of them to the height of double. But after double, it is float. So if one of them is a float, then we convert the other, which is lower than float, to float because we already passed double. Double is the first thing we check. If it is not a float, then we move to long and we move to the next one. So typecasting. We talked about typecasting in C. We said we have two ways of changing types. We have implicit, which is what is happening in this expression. This is the rule for implicit. In fact, what is going on here is automatic, and it is called implicit conversion. So what we have here is called implicit conversion or implicit casting. But if you don't want the compiler to do it for you, you want to do it for yourself, you have to do explicit. And this is what we call explicit. You put a converter in front of the type. So the converter here is int. It is forcing the type, which is 3.0, which is a float or a double. It's converting it and forcing it to become an integer. Because it is 0.0, we don't really care much about what is happening. But this is 0.9, we should care. Because we should know that 0.9 will be taken away. All right. Int x is equal to 5 divided by 2.0. What would happen? How will this be evaluated? 5 divided by 2.0. What is our rule? Let's assume that this is double. What is our rule? Our rule says if one of the expression is a double, the other guy is forced to become a double. So 5 becomes 5.0, not float, but double. It must be double. So we divide 5.0 divided by 2.0. Our result sensibly would be a double. So it's going to be 2.5. Now here comes the problem. We want to store 2.5 inside of x, but x does not care about 0.5 because x is an integer. What happens? What you are expecting? We cut off this part of 2, and so we store 2 in x. Okay, keeping 2 digits after the decimal point. You are familiar with this because I taught you formatting of print in C. If you want to print a specific number of digits. You have to put dot, the number of digits, F. You remember this in C. So it's the same as Java. Casting in an augmented expression. Um, this does not really matter because you know it. If you are trying to cast, what happens is the expression is broken down into what it really is. So if you say sum plus equal 4.5, but sum actually is an integer, it means 4.5 and the destination do not match. So what happens? What happens is the evaluation is done. We take sum, which is 0. We add 0 to 4.5, and the answer is 4.5. And then we try to store 4.5 back inside of sum. And at that time, integer will take over. Integer will say, okay, we know you are 4.5, but we don't care about your 4.5. The fact that you have to come inside an integer, you have to forget about your 0.5. And so we have 4 getting stored inside of sum. This is, I believe, what you already expect. Okay, so this is a program for payment of loan. You can check it again from this link. Okay, errors to avoid. Errors to avoid. You have to avoid the following error. Number one, undeclared or uninitialized variable and unused variables. Okay, unused variables are still manageable. Okay, Yeet, you have a question. Yeet, what's your question? Where is Yeet? What happened? Okay, I guess Yeet doesn't have a question anymore. Okay, mistakes students make in Java. First is they try to use X when they actually have not created X, or they try to use X when they have created X, but they have not put a value in X. So they have written double X. Then they go somewhere down and they say Y is equal to X plus 5, but X doesn't have a value. So this is an error of uninitialized variable. Integer overflow, trying to put 1000 inside of a variable of type byte is overflow. Round-off errors, when you are trying to do casting, you are moving from an integer into a float and you are cutting off the floating point part, you lose precision. Unintended integer division, you are doing a division by integer, and you should understand that if you're having two integers dividing each other, your result is going to be an integer, so you will lose precision. So what do? If you want to divide 7 by 3, you should know that your answer is 2. But if you want the floating point answer, even though the two operands are of type int, then you must cast. You must cast one of them to the type that you want the result to be. This way, the compiler needs to make sure that both of them are casted. Redundant input objects. Okay, this is not so common, but here is what it means. You made use of scanner. You created an object from scanner, but actually you're not collecting anything from the keyboard. So you just wasted the input object from scanner. It is a possible mistake, but it's not a common mistake. You can avoid it. Okay, so here are examples of them all. You are trying to use undeclared variable or you are trying to use uninitialized variable. What is the problem here? You have declared interest of capital R and Java is case sensitive, but you are trying to use lower R. So this is undeclared variable. Your code will not compile. Integer overflow. You are trying to store a value that is larger than int inside of the int space. Round-off error. The result of your evaluation produces the number of decimal points that is exceeding what can be represented. So it provides something that is different from the real answer. Okay, unintended integer division is this. You're dividing by 2. So the result is going to be 2. It's going to be integer because you are operating on integers. Whereas you were hoping that the result would be a double. So how do you solve this? You can cast one of them to double, or you can cast the divisor to double. So here, casting the divisor to double will solve the problem. Okay, we talked about this. If you create an object input, make sure that you make use of it. Because here, observe, you have used one input, you are making another one to use the next one, which is not necessary. You can use that same old one to get your next double. So don't make redundant input objects. All right, so this is the end of this chapter. Let's quickly take a look at the next chapter so we can know what is going on with the progress of our class. So selection structures. Let's just look at selection structures for a few minutes and then we will end the class. So most probably your lab will start next week, but let's see what we have in selections first. I mean, most probably your lab will start this week. Let's see what we have in selections first. But I said most probably, keep that in mind. The most important thing, the final announcement would be made through OLAN. Selections. Again, in C, we discussed selection structures. So this should be no problem to you, no problem whatsoever. Selection. So if you are making a calculation and you have to make options, you have to select values based on something that happens within the code, then you must be able to make selections. And this is why we have selection structures. So in the Java programming language, we have a new type that we do not have in the C programming language. We have the Boolean type. In C, we don't have Boolean. If you remember, when we are making use of logical expressions, or when we are trying to check output of comparison, in C, we say that it ends in either 0 or 1. So 0 is false, 1 is true. But Java explicitly has the Boolean type, which is either true or false. So the Boolean type consists of two possible values, true or false. And so for the Boolean type, we make use of relational operators and other operators do. So what we are trying to say is that here are Java's relational operators. Here are the symbols they look like in mathematics. And these relational operators, all the 6 of them, they provide for us Boolean results, either true or false. So they give to us either true or false results. Okay. In selection, we make use of if. You know this from C. And this is what the if looks like. We have the if keyword, some expression that evaluates to a Boolean type, and then the body of code that is executed if this expression is true. So we can have statement or statements right here. So here is the Boolean expression. If it is true, then we go to statement. If it is not true, then it is false. So we skip the statement and we continue after the group of statement that is inside the curly braces after it. Even for a larger one, here is what the system looks like. If radius is greater or equal to 0, then do this. So if radius is greater or equal to 0, we come down. If it is not, then we don't come down through the code. We come down after the code. Okay, so observe this, that we don't just write the expression without parentheses. You must put the parentheses. Unlike in C, where you can just write without curly braces, okay, it's actually good to put curly braces. This is the idea. It's actually good to put curly braces because it's derived from C also. You can write without curly braces if it is just one line. You remember that we said if it is just one line, it's a statement. If it is more than one line, then we have to make it a compound statement using the curly braces. So if it is one line, you can remove these curly braces and have expression like this. It will work. Okay. Again, please practice with the slides. Click on these links and see what the codes look like. Also, like we have in C, we can have two-way expression, which is if and else. So we check the expression. Instead of false not having a statement, false also has a group of statements that it evaluates. Okay. And sometimes we can have even multiple alternatives, not just if and else. We can have if, else, if, else, if, else under the same thing. You are familiar with this. We already know this in C. And the syntax is the same thing. The syntax is exactly the same thing. So here is the structure. Okay, I guess this are pretty simple things for you. Just the same structure of C. Also, we discussed this in C, is about the same thing. We evaluate the if of I is greater than J. If I is greater than J, then we want to check if I is greater than K. So if I is greater than J, we come here and we evaluate if I is greater than K. So if I again is greater than K, then we can print A. We are printing A. Else, print B. So the question is, who has this else? Who does this else belong to? If you look at the indentation, the else belongs to this first if. But Java is not indent sensitive. Java is grouping sensitive, grouping using curly braces. And that means this indent does not matter. And because of that, because this else needs an if, we attach this else to the nearest if. So as far as Java is concerned, we have if I is greater than K, else print B. So this else belongs to this if. So this is the better indentation because else belongs to the nearest if. The else clause matches the most recent if clause in the block, in the same block. This is important, in the same block. So if you wanted the else to belong to this, then you should group this with curly braces. So automatically, since the else is not in this block of the if, it is out of the block because the block ends here. Then we believe that this else is in the block of this if. Okay. Anybody has a question? Don't worry, Elif. I will make announcements. If I don't make any announcement, you don't have lab. If I make announcements, then you know from the announcement if you have lab. Remember, I wrote it on the previous announcement that currently you don't have announcement, you don't have lab, and you don't have lab until I change the announcement. So just stay without lab until I make an announcement. When I make an announcement, then you must attend your lab. All right. Common error. You know this already from C. Cannot put semicolon in front of if. Now, it will not be a compile error. Your code will compile. The only thing is that your code will do something that is different. What it means is there is nothing that should be done whenever this radius is true, whether radius is greater than or equal to 0. Whenever it is true, it shouldn't do anything because it should do what is between this parenthesis and this semicolon, which is nothing. So your code will never evaluate this part based on the result of this expression. It would always evaluate this part, no matter what this expression looks like. And because of that, you should know that you should not put semicolon here. It's very bad because it's a hard to find mistake. I mean, if your code would not compile, it would have been a good mistake because you can easily find it. But your code would compile, but you would have a wrong result. All right. If number mode 2 is equal to 0, then even is equal to true. Else, even is equal to false. So you can do this, but it's better to do it this way. Why? Because Boolean variables, by definition, their automatic value is false if you don't put true in it. So this makes it easy. Whenever we want to put true, then just assign the value of true into the even variable. But if you don't put true, then we know the value is already false. So this line is not needed. Boolean types are automatically initialized to false. Okay. If even is equal to true, okay. Because the if statement wants to see a Boolean expression here. Because of that, you can actually put the Boolean variable inside of the parentheses alone. You don't have to compare a Boolean variable with a Boolean value before you can decide if this is true or false. So let's assume that the value of even, let's bring our code here. So let's say the variable even, Boolean even is equal to false. So you say if even is equal to false, do something. Now, what you are saying is, what is inside of even? False. If, okay, let's change this from false to true. So we are saying if even, which is false, is equal to true. So what we are saying is if false is equal to true. And this is not true. False is not equal to true. So it comes outside there to evaluate. But we are saying that you actually don't need to test this. If you just say if even, what is the value of even? False. So it does not do anything. It just say, okay, if false, because what we are actually using is the result of the entire expression. And this entire expression is false is equal to true. No, the value of this expression is false. So if we know that we are actually using the value of this expression, then we don't actually need to have a complex expression. We can just use the value in even. So we are saying if even, what is even? False. So don't do anything. If you change this to true, then it says if even, what is even? True. If true. So it is true. So it comes and it does something. This is a very interesting trick you can use in programming. Okay. Logical operators. Does somebody have a question? Okay, logical operators. We have different logical operators in Java. We have this, which is the logical not. This is the logical and. This is the logical or. And this is the exclusive or. I guess you already saw this in C. The policy is still the same thing for the operators, just exactly what we have in C. The only time two operators provide true, the only time two operators provide a true result in logical AND is when both of them are true. This is the only time we will get true. Other times it's false. Other times the result will be false. For OR, every time it is true, or let's use the opposite. The only time the result is false in OR is when both of them are false. When both of them are false, that is the only time it is false. But whenever we have any true, then the result is true. Now, for exclusive OR is very similar to OR. The only difference is that it does not want the two of them to be true. One can be true, we want it. But for two to be true, we don't want it. So this is the difference between OR and exclusive OR. Okay, so you can get this from the example codes. These are just codes that you can check from the slide. Now, just click on this link and it takes you straight to the website. Any question? Okay. So switch. Switch is similar to what you are familiar with. Switch is just the same switch that you know in C. So switch is the same switch that you know in C. You switch based on a value. By the way, I guess you remember that this cannot be a changing expression. This must be a fixed value. Switch based on something. Case 0, case 1, case 2, or whatever. And so if the status is 0, we do something specific. If it is 1, we do something specific. By the way, status is not status in English. Status is the name of a variable. The name of a variable. Okay, so the same idea. We are switching based on a switch expression, and then this is the body of the entire switch. Inside the body of the switch, we have different cases. And whenever a case value matches the switch expression, then we evaluate the statements inside that case. And just like we have in C, every case must be separated with the break, except if you want the case to not stop when it finishes. If you want it to move into the next case, but if you don't want, every case should end in semicolon. Okay, the switch expression must use the value of char, byte, short, or int type, and must always be enclosed in parentheses. So this expression must yield these types for it to be valid in Java. The value 1 till value n, these values must be the same type as the result of this. So if this expression gives us a char, so what we are saying is that all of these, value 1, value 2, value 3 till value n, must also be char. So you cannot have different types between what you are checking and from what you are checking it. So you cannot have different types in these two. These two of them must be the same type. Okay, break is optional, like we said, but it is important if you want the case to stop at the end of that case. Okay, so we know this. We already learned this in C. This is an expression. Okay, we know this also. This is the conditional operator, but in C we call it the ternary operator because it is the operator that makes use of 3 operands. It is the only operator that uses 3 operands. So this is operand 1, this is operand 2, and this is operand 3. So what does it mean? It's an if statement. So it says, if this expression is true, then evaluate this one. If this expression is false, then evaluate this one. This is the meaning. Okay, operator precedence in Java. We have the increment operators and decrement operators as highest. Then we have the unary arithmetic operator and the the prefix increment and decrement. This is the postfix increment and decrement. The prefix is after the postfix. After that is explicit casting, when you want to cast explicitly. Then the negation, the multiplication, addition and subtraction, relational operators, equality, exclusive or, logical and and the compound assignment. Okay. Any question from anybody? Okay, Tinadu, what's your question? You can write it in the chat or you can say it. I'll wait for both. Any question? Okay. It seems Tinadu doesn't have a question. Probably it's just a mistake. Okay. All right. So we'll stop here and we'll see next class. If there will be lab, I'll check the lab materials and send you an announcement very soon. If there won't be lab, you will receive no announcement. So take good care of yourselves. Please make sure that you go through the slides because we have them all on Holan. Go through the slides, check the things out. If you have confusions, get your questions ready. Next class, we'll solve your questions. All right, take care. Bye-bye.
Teacher, there is any attendance or not?
No, by being in the class, you already took attendance. It's
Okay.
automatic.
Okay.
Yusuf, are you in the class? I will make announcement.